the three-phase currents IR, IY, and IB. And you know IR is normal current, IY is IR minus 120, and IB is IY minus 120, or it is IM cos omega t minus 240, or it is IM cos omega t plus 120. So you have three components of three-phase current IR, IY, and IB. Now we are going to find what is the flux density BR, BY, and BV. So BR will be same thing only. Additionally, you will get a cos theta m term. Okay, so BR of t comma theta m will be the same as IR term, IBM cos omega t cos theta m. And this cos theta m is coming because of rotation. BY is BM cos omega t minus 120 into cos theta m minus 120. And BB is cos BM cos omega t plus 120 cos theta m plus 120. See, whenever you are subtracting this angle, you have to do it for everything, because it is fully subtracted, fully it is rotating, right? So you have to subtract it for everything. So BR, BY, and BB. For BR, nothing. For BY, it is omega t minus 120, means cos theta m minus 120. BB, it is BM cos omega t plus 120 and cos theta m plus 120. You can also use minus 240 for both. That is also correct. Anyways, now when we are adding all the things, to add all the magnetic flux density, BR plus BY plus BB. So BR is BM cos omega t cos theta m, BM cos omega t minus 120 cos theta m minus 120, plus BM cos omega t plus 120 cos theta m plus 120. So add all the magnetic flux density. When you add all the magnetic flux density, you are going to, I'm going to group the terms like this. So group omega t minus theta m and omega t plus theta m, omega t minus theta m and omega t minus theta m minus 240, omega t minus theta m and omega t plus theta m plus 240. So use cos of a plus b plus cos of a minus b formula, and if you simplify, you will get this one. And when you apply the trigonometric identities, the inner terms will become 0. So these three terms are going to become 0. So when these three terms become 0, only the first term is remaining. So B of theta t comma theta m will be Bm into 3 by 2 cos omega t minus theta m. So I am going to write this 3 by 2 Bm as Br cos omega t minus theta m. So this is the rotating magnetic flux produced when all the coils are operating together. And the maximum value of the magnetic field is going to be 3 by 2 into Bm. It is 1.5 times more than your Bm. Okay. So see, the three-phase currents add panna 0 ஆயிடும். But three-phase magnetic fields add panna, it is not 0. Very, very important thing, please understand. I told you, in star or delta connected three-phase system, whenever you are going to add the current or voltage at any point, it is going to be always 0. But when you add the magnetic field generated because of these three-phase windings, they will not be 0. You will get a non-zero field existing. So that field is given by Br cos omega t minus theta m. Br is the maximum amplitude given by 3 by 2 Bm of the rotating flux density and omega, it depends on T and theta m. So we have assumed, right, magnetic field is rotating, so it depends on theta m, and I'm going to supply AC, so it depends on T. So see here, this formula has the terms for T as well as theta m. So B of T comma theta m is going to be Br cos omega t minus theta m. So this equation, what we have derived, it has the following properties. The magnitude is 50% greater than what each coil gives. See, actually, Bm. But what is the final answer? We get 1.5 times Bm. So 50% additional magnitude we get. And if time is fixed, the maximum flux density is theta max equal to omega t. And if time is equal to 0, maximum flux occurs at 0. What they are saying is, if you are going to fix your time, then maximum magnitude occurs at an angle theta m. If you are going to fix your theta, maximum magnitude occurs at t is equal to 0. So two variables are there, right? So you cannot vary them simultaneously. So you have to keep one thing constant to find the effect of another. So first thing what they are saying, see the second point, if the time is fixed. So if you are going to fix the time means The time t is a constant, so equate this term to 0. So theta max will be equal to omega max into t. See here, theta max equal to omega into t. Maximum occurs at this angle. If time is equal to 0 means, cos of minus theta m, cos of minus theta m is cos theta m. The maximum occurs at theta m equal to 0. So these are the two conditions. When will the maximum occur? When time is constant and the angle is constant. Okay. When the angle is going to be constant, it is going to be sinusoidal. The peak value is given by Tp equal to theta m by omega. Same way, equate this term to 0. So omega t minus theta m equal to 0. So t is equal to theta m by omega. Same equation. See here, theta equal to omega into the same equation. I'm rewriting here. So t will be equal to theta m by omega. Same thing. Okay. So one duration will be theta is equal to omega t. Omega is 2 pi f. T is 1 by f, 1 by frequency. So when you cancel the frequency term, theta will be equal to 2 pi. Okay. So this is the maximum. The when we are going to have two pole in a machine, so the electrical angle is given by 2 pi electrical radians, and it can be shown if you are going to change your three phase from RYB to RBY, direction of rotation will also change. If it is minus theta m for RYB, it is going to be plus theta m for RBY. So in case if you are going to change the sequence of the three phase windings, the angle will also change. So that one you have to understand. We have already seen all these properties in three phase network. Just a summary of all these things. Okay.